Hi Math 7 students, I hope you had a good weekend and that you're ready to learn your next math lesson. So let's get started. Father in heaven, I just thank you so much that you're faithful and you're good. I pray for all of my students that they would focus and learn this material very well and do great on their Chapter 11 test, and you'd strengthen me and help me to be the very best teacher I can be. In Jesus' name, amen. Okay, well, one thing I want to say, and I hope that you show this to your parents, is that it would be a great idea for you to have a calculator. With the square roots and a lot of the answers being in decimal form, I really think that having a calculator would be beneficial to you. So it's a special kind of calculator. It could be a TI-30, that's one model that works really well, or just a simple calculator that has the square root button. That's what you need. I don't want anybody using their cell phones, because if I let you use it during the test, I don't want you to have your cell phone during the test. All right? So let's get started with lesson 11.5. Okay. So here we go. 11.5 is about the area of triangles and trapezoids, okay? So let's look at a problem. I want to pull up a picture for you. Isn't this cool? This is in Cleveland, and it is the Rock and Roll Hall of Fame. And do you see that shape there? There's a triangle entrance. It's really quite dramatic to that museum. So I'm going to read, while you look at that, I'm going to read the problem. The Rock and Roll Hall of Fame and Museum in Cleveland, Ohio has a rectangular shaped wall as shown. What is the area of the wall? Do you think that was important? Do you think they figured that out at some point? Absolutely they did. They had to figure out how much glass they needed for building it. They probably had the glass coated with something to protect it. If they're ever going to wash the glass, they have to know how big an area is for cleaning and for buying soap. And there's also a lot of cement and different things in between the windows. So anyway, there's a lot of reasons why they would want to know how big this shape is. So let's figure it out. Okay, number one. It has a shape like this in the front, and this is our own triangle, and they tell us that the height here from top to bottom is 111 feet. Now just to put that in perspective, that's like at least 10 stories. So that's tall, all right? And 231 feet across, that is about a little more than 2/3 the size of a football field. So if that's just the front of a building, that's a large building, very large building. So our area formula for a triangle is 1/2 base times height. So whatever you have for the base and the height, you multiply it by 1/2 for a triangle. So with knowing that, I'm going to put the numbers in that I have. So I have 1/2, and the base is 231, and the height is 111. And when I figure that out, I get 12,820.5 feet squared. Now be careful, it's important. When you figure out area, your units change. It's not just by the length of a foot, it's the unit size is a square foot, so it's actually a square block, like the size of a tile on your floor. So how many of those squares do you have? All right, so that's the first one. And number two, find the area of the triangle and we have a base of 7 meters and a height of 13 meters. Okay, so really it's just practicing using the formula. So if I had this, I would 1/2 times the base, which is 7, and the height, which is 13. 7 times 13 is 91. And when I take half of that, I get 45.5 meters squared. That's my answer. Okay, so I want to give you some OIOs to practice this. Find the area of the triangle. Okay, number 1, the base is 10 and the height is 12. And number 2, the base is 8 and the height is 6. Okay, so why don't you go ahead, I'm going to go get my cell phone, which has my calculator on it. I just want to have it with me. Go ahead and work on those two, and we'll come back in just a moment. Okay, so let's go over these. Let's see what we get. 1/2 10 times 12, and that would be 120, and half of that is 60. Okay, so that's my first answer. And then 1/2 base times height. This is the work that you show. You want to show substituting your numbers in so I can see what you did, especially to justify what you did right, as well as to show me where you may have made a mistake. So this becomes half of 48, which is 24. Okay, I have another picture to show you for the next example. And that is this building, okay? That is called the Flatiron Building in New York City. So apparently you had these two streets coming down here like this, and somebody wanted to put a building there, so it's the shape of a triangle. And you can see on the top, you have a triangle there. So that's a very cool building. If you ever get to go there, you can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, at least 20 stories. It's really quite a feat. And it must be pretty interesting to be in one of those rounded cornered rooms. Okay, so let's go back to the problem. And it says, from above, the Flatiron Building in New York has a shape that can be approximated by a right triangle. So this is number 3, and a right triangle that looks like this, and here's our right angle, and it has a height of 87 feet, and the area they give us is 7,525.5 square feet. And the question is, find how long the base is. Find its base. So I'm looking for this here, which is a B. Okay? I want to know how long it is going along that street. So let's look at this. The area is 1/2 base times height. And this time I know the area. These are a lot like these problems that we did last time with the parallelogram, where we were given the area of the parallelogram and we had to find the base of the height. It's very similar, okay? So I don't know B, so I'm going to put B in, and the height is 87. All right? So now what I'm going to do is half of 87, this becomes now an algebra equation, and half of 87 is 43.5b. So I have 43.5 times b. So if I want to get b by itself, I do the opposite function, which is to divide. And when I do that, I get 173. So the length of the base of the building is 173 feet long. Not feet squared, we're looking for a length. All right, now that's what we're going to learn about triangles. Now we're going to move on to trapezoids. So here's a formula. The area of a trapezoid looks like this. A equals 1/2 times B1 plus B2 times H. Now what that means is a trapezoid typically looks like this. So we have B1 and B2 here. So one base is different than the other base. If they were the same, then I would have either a rectangle or a parallelogram, which I don't. So they're different, and the height is this perpendicular distance. Make sure it's not the slant. Not the slant. The height is the perpendicular distance. So this is my formula. So what I do is I put the two numbers in, add those, and then I multiply by 1/2 and by the height. So let's look at a real example. This is number 4. Find the area. And we have a picture like this. Eight, 5 feet, and 10 feet. So I'm just going to put my numbers in. Alright, so first I'm going to write down my equation, just because I always like to have it there, and I make sure that I put every number in that has to go in. So I'm going to have 1/2, and then B1 is 5, B2 is 10. Now the height, be careful, it's not 9, it's not my slant, it's going to be 8. Now when I work this out, it goes back to PEMDAS. So I do my parentheses first. So I've got 1/2 times 15 plus 8. I add the 5 and the 10. Okay, now I'm going to take half of 8. That's easiest because it's even. So I have 4 now, and 4 times 15 is 60. And that's going to be feet squared. All right, that's number 4. And then number 5, a trapezoid has an area of 66 meters squared. The bases are 8 meters and 14 meters. Find the height. Okay, so I have the area already. I'm still going to use my equation. I'm just not going to solve for the area. I'm going to solve for the height. Okay, I'm going kind of fast. If you want to pause it and write this down, please do. The shorter the video, the quicker I can upload it for you. Okay, so area here I know is 66. And my bases are 8 plus 14. And I just want to solve for the height. Okay, so we're still going to add inside. So 8 plus 14 is 22. Half of 22 is 11. And then I divide by 11 to get 6. So the height is 6. I hope everybody understands that okay. All right, last one before the OIOs, number 6. Flowers are planted in a public garden in the shape shown. What is the area of the garden? Of the garden. Okay, so here's our picture. And they tell us that this is 3 yards. This is 8 yards. And this perpendicular distance here is 5 yards. And the bottom is 6. So I have a pentagonal shape, but I don't know how to find the area of that. You'll have to wait till geometry. There's a special way to do that. But in the meantime, I can do the parts. So if you look at the parts, you can figure it out. The area of the whole thing is going to be what? I've got, let me use a different color. I've got a trapezoid right here. So I have 1 trapezoid plus 1 triangle. So if I find the area of each thing, then I can add them together. So let's do the triangle. That would be 1/2 base times height. So what do I have here? This is 8 and this is 3. So I'm going to have 1/2, 3 times 8, which works out to be, let's see, 3 times 8 is 24, and half of that is 12. So I have my triangle. And then the trapezoid,